In this video, we solve a sample problem using a systematic approach. We demonstrate each phase with a special focus on algorithm design. We also introduce a new approach to testing. Here is a sorted list of items. A new item is added at the end. Now the list needs to be resorted. We could use the bubble sort to sort the list. There seem to be too many unnecessary comparisons. Maybe, we can compare the new item to each item in the list. We found its place in the list. But the larger items need to be moved, to make place for it. If we're going to move the larger items, we might as well do that at the time of comparison. First we take out the new item, leaving an empty position in the list. If the item in comparison is larger than the new item, move it. Once an item in comparison is smaller or the same, we can insert the new item into the empty position. This approach seems best. It makes only the necessary comparisons and moves items at the same time. We assign the new item to a temporary place, to make room for moving larger items. The current index always points to the position where an item can be moved. The item before the current index is compared to the new item. If it's larger, move it to the current index. And the current index now points to the position where the moved item used to be. We repeat this process until there are no more larger items to move. Finally, move the new item to the current index. Now consider this. Since the item before the current index is compared, the current index must stop before the first index. Otherwise, we run out of bounds. Here's the pseudocode. We use the while loop to move the larger items. When the loop completes, we have found the place for the new item. Now we can expand this to support additional new items. The marked index points to the first unsorted item. The range of unsorted items run from the marked index to the last index. We use the for loop to iterate the unsorted items. The index points to the first unsorted item. Add the remaining pseudocode, and we're done. We use a function to encapsulate the algorithm. The function accepts two inputs: the source list, and the marked index of the first unsorted item. From the main program, we call the function, like this. 3 is the index of the first unsorted item in my list. And here's the implementation for the function. It has two local variables. The for loop iterates the unsorted items from the marked index to the last index. The while loop iterates the sorted items and moves the larger items. In this video, we introduce a new testing method. The path testing is a method of creating test cases, based on the control flow diagram. The cyclomatic complexity is a mathematical formula for calculating the number of code paths. The edges are the lines, and the nodes are the shapes in the diagram. For the sorting algorithm, there are 11 edges and 9 nodes. So there are 4 unique code paths to cover in our testing. This code path checks for the validity of the marked index. To test the path, we call the function with a marked index, equal to myListLength. This code path checks for the case when the current index has reached the first item in the list. To test the path, we call the function with a marked index, 0. This code path checks for the case when the sorted item is smaller or equal to the new item. To test the path, we call the function with a marked index larger than 0 and myList already sorted. This code path checks for the expected case when larger items are moved to insert a new item. To test the path, we call the function with myList partially sorted.